In this video, we are going to deal with the distribution problem, and we have this question here. The question tells us that there is a certain factory that produces these optical lenses. So, out of these 500 lenses that it produces, there will be one that will be defective. So, this will be the probability of getting this defective lens. That will be 1 by 500, and the lenses are supplied in packets of 10 each. That means when we perform the experiment, we'll perform the experiment on these 10 lenses. That means this is a packet. So this is an independent case. So you'll uh, check whether glass is defective or non-defective, and you put that glass back into that packet, and you shuffle that, and you perform the experiment again. So this experiment will be conducted 10 times. So what is the probability that a packet will contain no defective lens, at least one defective lens, at most two defective lens? So if we want to understand this question, so we can move on to the diagram given below here. So in the diagram here, you can see there are 10 glasses, a packet, and there is either a success or a failure. So this is the Bernoulli trial. That means you will either have successful experiment or failure experiment. So it depends on us what we interpret the success or the failure. So in the question, we have to find the probability that a packet will contain defective lens, no defective lens, at least one defective lens, at most two defective lens. So these all things are related to the defective lenses. It only tells us to find the probability of these defective lenses. So we it will be easier for us to interpret success as the probability of getting these defective lenses. So we have written the success as the probability of getting these defective lenses, and the remaining is obviously the failure, because the total probability will always be 1. So if we subtract 1 by 500, we will get the failure. And this is the case of binomial distribution, and you can calculate the expectation or mean, that will be the product of the sample size and the success, that will be the 0.02. So this is very much less, and it is less than 5. So we can do this distribution with the another process, or the Poisson's distribution. So you can also go with the binomial distribution, but I prefer the Poisson distribution. So if you look onto this Poisson distribution formula, you get the e to the power minus lambda into lambda to the power x on the numerator, and on the denominator we have the x factorial. So this lambda is nothing but the mean that you are getting here. This will be the 0.02, and this x here will be the discrete random variable associated with the number of glass that are defective. So this is related to success. So we have labeled the success as the probability of getting the defective lenses. So this x for the question number 1 will be 0, because the probability that a packet will contain no defective lens, this means that the success, for this success, we have to get the 0 defective lens. So for no defective lens, x equals 0, you can put the x0 here and you will get the 0.98. For the question number 2, we have to find the probability that the packet will contain at least one defective lens. So what we have to understand here is that while the question is saying that we have to find the probability of at least one defective lens, that means we can either get one defective lens, or 2, 3, 4, 5, 6, all the way to 10. So this is only talking about at least one. So it can be one and more than one. So more than one, it will go all the way to the sample size number 10. So that will be kind of difficult to calculate and consume more time, so I can perform the uh, rule or condition from the total probability. That will be 1 minus probability of x is less than 1. So this we have already calculated, because x is strictly less than 1 will be x equals 0. So 1 minus 0.98 will be 0.02. And this is the probability of getting the at least one defective lens, which will be 0.02. So for the number 3 part, we have been given at most two defective lens. That means we can either get x equals 0, we can get either x equals 1 or x equals 2. This is the maximum case of getting two defective lenses. So we can just write px equals 0 plus px equals 1, px equals 2. So combining all these, we get the value 1. So uh, we are getting 1 here because the probability is higher due to this probability of x equals 0, because while we are dealing with at most two defective glass, there can be no defective glass, or we may also get no defective glass, and it has considerably amount of high probability, so we are getting this 1. So this is all about this problem. Thank you.